FCC GROL Element 1 and 3 Practice Exams. Hey, you there. Want to pass your FCC GROL test this year and get that license? Stick with me. I will show you some practice questions that will make it easy for you. This is just a part of the complete course. You can get the link in the description for the complete practice questions with explanations, which will help you get your certification. I have also put a link to my Udemy practice test and a special Etsy visual guide for those who like to see how things work with pictures. If you like these questions, leave a comment below with your score or what you want me to explain more. And don't forget to subscribe for more videos like this. Now, to help you learn quickly, let's start with Section 1. Section 1. FCC Rules and Regulations. The FCC makes rules for radio use on ships and boats. These rules keep everyone safe and make sure radios work well. You must follow them if you operate a marine radio. Vessels need FCC certification for Part 80. That means the equipment passed tests and will not cause interference. You cannot use home radios or untested gear. Small passenger boats that go 20 to 150 miles from land need extra equipment. They must have an MF hydrogen fluoride SSB transceiver for longer range calls. Distress calls use special gear. A DSC controller sends automatic alerts to other stations or to start a distress message. Medium frequency transmitters on required ships need at least 60 watts PEP. This power helps reach coast stations on 2182 kHz. FM voice transmitters on ships cannot go over 25 watts carrier power. This limit stops too much signal strength. You need the right license to operate. A fixed radar set with outside controls needs no special license. But aircraft radios below 30 MHz on non-shared frequencies need a marine radio operator permit. People who cannot speak English on the phone cannot get a license. Foreign operators with IMO papers may qualify in some cases. Passenger ships with GMDSS need 2 operators with GMDSS licenses. Great Lakes ships need at least a marine radio operator permit. The person in charge of the radio must carry their original license or a copy. You show it if someone asks. You must listen on VHF channel 16 all the time for distress calls. Cargo ships at sea watch both 2182 kHz and channel 16. Non-GMDSS ships monitor channel 16 when at sea. Silent periods on 2182 kHz happen at 00 and 30 minutes past the hour. No calls then, except distress. DSC watches cover VHF channel 70, MF2 MHz DSC, and some HF bands. Only the person responsible for the station writes in the log. The station licensee and operator in charge both keep the log safe. Logs stay at the main radio position during the trip. To fix a mistake, draw a line through it, write the correct info, and initial it. Logs with distress entries stay for 3 years unless the FCC says otherwise. Normal logs keep for 1 year from the last entry. Every log must show station name, date, time, operator on duty, and call signs you talk to. EPIRB tests go in the log every month. GMDSS logs stay at the operating position and allow short abbreviations if you explain them. Ships in international waters follow FCC Part 80 and international radio rules. An unlicensed person can speak on the radio if a licensed operator watches them. You apply for ship station inspections at the FCC District Engineer Office. The ship captain has final say over the radio station. The main radio position must sit in the room where the ship steers at sea. Cargo ships over 300 gross tons or ships with over 12 passengers on international trips must carry radio gear. These rules sound simple, but they protect lives at sea. Study them well. You will see them on the test. 1. What is a requirement of all marine transmitting apparatus used aboard United States vessels? Only equipment that has been certified by the FCC for Part 80 operations is authorized. The FCC tests the gear so it works safely and does not bother other radios. 2. What transmitting equipment is authorized for use by a station in the maritime services? Unless specifically accepted, only transmitters certified by the Federal Communications Commission for Part 80 operations. S. Standards. 3. Small passenger vessels that sail 20 to 150 nautical miles from the nearest land must have what additional equipment? MF hydrogen fluoride SSB transceiver. It gives longer range for help calls when far from shore. 4. What equipment is programmed to initiate transmission of distress alerts and calls to individual stations? DSC controller. DSC sends automatic digital distress signals fast. 5. What is the minimum transmitter power level required by the FCC for a medium-frequency transmitter aboard a compulsorily fitted vessel? At least 60 watts PEP. This power reaches coast stations reliably. 6. Shipboard transmitters using F3E emission, FM voice, may not exceed what carrier power? 25 watts. Higher power could cause too much interference. 7. Which commercial radio operator license is required to operate a fixed-tuned ship radar station with external controls? No operator authorization is required. Fixed radar sets do not need a special license. 8. When is a marine radio operator permit required for aircraft communications? Below 30 MHz, on frequencies not exclusively allocated to aeronautical mobile services. This covers shared bands used by planes. 9. Who is ineligible for a commercial radio operator license? An individual who is unable to communicate by telephone in English. You must speak English clearly for safety. 10. What are the radio operator requirements of a passenger ship equipped with a GMDSS installation? 2 operators must hold a GMDSS radio operator license or a restricted GMDSS radio operator license, depending on the ship's operating areas. Extra trained people handle modern distress systems. 11. What is the minimum radio operator requirement for ships subject to the Great Lakes Radio Agreement? Marine Radio Operator Permit. These waters have special rules but still need basic licensing. 12. What is a requirement of every commercial operator on duty and in charge of a transmitting system? The original license or a photocopy must be posted or in the operator's personal possession and available for inspection. Inspectors can check your papers anytime. 13. What is the compulsory radio telephone station watch? VHF channel 16 continuous. Everyone listens here for Mayday calls. 14. What is the continuous watch requirement for a compulsory cargo ship not carrying GMDSS equipment and not in a VTS area? Watch on 2182 kHz and channel 16. Both frequencies catch distress signals. 15. What channel must non-GMDSS vessels monitor at sea? Channel 16. It is the International Distress and Calling Channel. Section 2. Communications Procedures. Radio talk follows clear steps. You call, identify, and keep messages short. This helps everyone understand you. Bridge-to-bridge uses VHF for close ships to avoid crashes. The Vessel Traffic Service, VTS, helps in busy areas. You can use more than 1 watt on bridge-to-bridge only for distress or when you cannot see around a bend. Channel 13 is for bridge-to-bridge. You say your ship name instead of call sign when close. Distress calls start with Mayday 3 times. Then give your position, nature of trouble, and help needed. Urgency uses pan-pan. Safety uses Securite. You test radios weekly and log it. Battery tests daily for GMDSS. Inmarsat or satellite calls follow the same voice rules. When you hear a distress call, write it down and help if you can. Do not talk on the frequency unless asked. Routine calls use, this is, after your call sign. End with, over. Phonetic alphabet helps spell words, Alpha, Bravo, Charlie. You log every distress, urgency, and safety message. These steps save time and lives. Practice them out loud. 1. S. Coast Guard Service to prevent collisions. Vessel Traffic Service, VTS. VTS directs ships in busy harbors. 2. What is a bridge-to-bridge station? A VHF station located on the navigational bridge. It lets the captain talk to nearby ships. 3. When may bridge-to-bridge transmission power exceed 1 watt? In a blind situation, river bend, or for distress. Extra power helps when sight is blocked. 4. What is the primary purpose of bridge-to-bridge communications? To exchange navigational information between vessels. It stops accidents in close waters. 5. How do you identify a ship station on VHF bridge-to-bridge? Use the ship name instead of call sign. Names are easier for quick talk. 6. What is the correct way to start a distress voice call? Say, Mayday, 3 times. This word tells everyone it is life or death. 7. What does pan-pan mean? Urgent message about safety of a person or ship. It is serious but not full distress. 8. What is the proper way to end a radio transmission? Say, over. It tells the other person it is their turn. 9. How often must you test GMDSS equipment? Weekly for radio telephone tests. Regular checks keep it ready. 10. What must you do when you hear a distress call? Log it and offer help if possible. Everyone helps in emergencies. 11. What is the international distress frequency for voice? 2182 kHz and VHF channel 16. All ships watch these. 12. How do you spell difficult words on radio? Use the phonetic alphabet. Alpha, Bravo, etc. Avoid mistakes. 13. What is a silent period on 2182 kHz? 3 minutes at 00 and 30 minutes past the hour. No routine calls, only distress. 14. What do you log for every radio contact? Time, call signs, and station name. Logs prove what happened. 15. Who has final authority on a ship radio station? The ship's master. The captain decides all radio use. Section 3. Electrical principles. Electricity flows in circuits. Voltage pushes it, current is the flow, resistance slows it down. Ohm's law says voltage equals current times resistance. Use it to find any one value if you know the other two. Power is voltage times current, measured in watts. A 12-volt battery with 2 amps gives 24 watts. Capacitors store charge. Inductors store energy in magnetic fields. Resistors turn electricity into heat. AC current changes direction. DC flows one way. Radios use both. Frequency tells how many cycles per second. Hertz is the unit. Radio waves have high frequencies. Waveforms show sine waves for AC. Square waves appear in digital signals. Conductors let current flow easy. Insulators stop it. Copper is a good conductor. Plastic is an insulator. Semiconductors like silicon control current. Diodes let current go one way. Meters measure voltage, current, or resistance. Always set the right range before you connect. These basics help you fix radios later. 1. What is the basic unit of electrical current? The ampere. 1 ampere is 1 coulomb per second. 2. What is Ohm's law? Voltage equals current times resistance. It helps calculate values in any circuit. 3. What is the unit of electrical power? The watt. Power shows how much work electricity does. 4. What does a capacitor do in a circuit? Stores electrical charge. It smooths voltage or blocks DC. 5. What does an inductor do? Stores energy in a magnetic field. It opposes changes in current. 6. What is the difference between AC and DC? AC changes direction, DC flows one way. Radios use AC for signals. 7. What is frequency? Number of cycles per second, in hertz. Radio stations have specific frequencies. 8. What is a sine wave? A smooth up and down waveform of AC. Most radio signals start as sine waves. 9. What is a good conductor? Copper or silver. Electrons move freely in them. 10. What is the function of a diode? Allows current in one direction only. It rectifies AC to DC. 11. What does a voltmeter measure? Voltage. Always connect in parallel. 12. What does an ammeter measure? Current. Connect in series. 13. What is resistance? Opposition to current flow. Measured in ohms. 14. What is a semiconductor? Material like silicon that controls current. Used in transistors and diodes. 15. What is the product of voltage and current? Power in watts. Tells how much energy a circuit uses. That is the end of the first 3 sections. Get the full course in the description for all 6 sections plus more practice and explanations. Section 4. Components and circuits. We move on to parts that make radios work. Components like resistors, capacitors, and transistors handle electricity in different ways. They form circuits that do jobs like amplify signals or filter noise. A resistor limits current flow. It turns extra energy into heat. Use it to control voltage in a circuit. Capacitors store charge between 2 plates. They block DC but let AC pass. Good for timing or smoothing power. Inductors are coils that store energy in magnetic fields. They resist changes in current. Combine them with capacitors for tuned circuits that pick frequencies. Diodes let current go one way only. Like a check valve. Zener diodes regulate voltage by breaking down at a set point. Transistors act as switches or amplifiers. Bipolar types have NPN or PNP layers. FETs use fields to control flow. SCRs and triacs switch high power. SCR for DC, triac for AC. LEDs light up when current passes. Photodiodes detect light and make current. Op-amps amplify differences between inputs. They make comparators or filters. Phase-locked loops track signals for stable frequency. Digital logic uses gates like AND, OR, NOT. They process binary info. Flip-flops store bits. Counters count pulses. Memory holds data. Microprocessors run code. Schematics show how parts connect. Read them to build or fix gear. RC circuits have time constants. Tau equals R times C. It sets how fast things charge. Impedance combines resistance and reactance. In series, add them. In parallel, use formulas. These building blocks let you understand radio insides. Practice drawing simple circuits. It helps on the test. We cover practical stuff too. Like how a transformer steps voltage up or down. Mutual inductance links coils. Materials matter. Conductors like copper carry current easy. Insulators like rubber stop it. Semiconductors like silicon are in between, doped to make N or P types. Waveforms show voltage over time. Sine for AC, square for digital. Meters measure. Voltmeter in parallel, ammeter in series. This section builds on basics. Get comfy with symbols and math. You will fix real problems. 1. What device stores electrical energy in an electrostatic field? Capacitor. It holds charge between plates, useful for filters or timers. 2. What is the function of a resistor? To limit current flow. It opposes electricity and drops voltage. 3. What does an inductor do? Stores energy in a magnetic field. Coils resist current changes, key in tuners. 4. What allows current in one direction only? Diode. It acts like a one-way valve for electrons. 5. What regulates voltage by avalanche breakdown? Zener diode. It keeps output steady despite input changes. 6. What amplifies or switches signals? Transistor. Controls large current with small input. 7. What switches AC power? Triac. Handles both directions, used in dimmers. 8. What emits light from current? LED. Efficient for indicators or displays. 9. What detects light? Photodiode. Converts photons to current. 10. What amplifies voltage differences? Operational amplifier. Versatile for many circuit functions. 11. What locks onto a frequency? Phase-locked loop. Tracks signals for demodulation. 12. What is a basic digital gate? AND gate. Outputs high only if all inputs high. 13. What stores a single bit? Flip-flop. Holds state until changed. 14. What is the time constant in RC circuits? R times C. Measures charge time. 15. What combines resistance and reactance? Impedance. Total opposition in AC circuits. Section 5. Transmitters and receivers. Now we look at how radios send and receive. Transmitters turn voice into waves. Receivers pull them back. A transmitter starts with an oscillator. It makes a carrier wave at set frequency. Modulator adds info like audio. Amplifiers boost the signal. Class A is linear but wasteful. Class C efficient for FM. In SSB, suppress carrier and one sideband. Saves power, narrow bandwidth. FM changes frequency with audio. PM changes phase. Pulse modulation samples signal. Used in digital. Antenna matches output. Tune for low SWR. Receivers use superheterodyne design. RF amp boosts incoming signal. Mixer shifts to if. Local oscillator sets the shift. If amps filter and amplify. AGC keeps volume steady. Detector pulls audio out. For AM, envelope detector. For FM, discriminator. Squelch mutes noise when no signal. Sensitivity measures weak signal detection. Selectivity rejects nearby stations. Image rejection stops false signals. Filters like crystal or ceramic sharpen response. Noise figure shows added noise. These systems work together. Transceivers combine both. Propagation affects range. HF bounces off ionosphere. VHF line of sight. Marine uses VHF for short range, HF for long. Aircraft nav like VOR gives direction. Safety first. Avoid RF burns. Study block diagrams. They show signal path. Practice calculations like deviation in FM. This helps you troubleshoot. 1. What generates the carrier wave? Oscillator. Produces steady frequency for modulation. 2. What boosts signal strength? Amplifier. Increases power for transmission. 3. What is suppressed in SSB? Carrier and one sideband. Reduces bandwidth and power use. 4. How does FM work? Varies frequency with audio. Constant amplitude, resistant to noise. 5. What samples the signal? Pulse modulation. For digital transmission. 6. What design do most receivers use? Superheterodyne. Converts to fixed if for easy filtering. 7. What shifts frequency? Mixer. Combines with local oscillator. 8. What controls gain automatically? AGC. Keeps output level constant. 9. What extracts audio from AM? Envelope detector. Follows signal peaks. 10. What mutes weak signals? Squelch. Reduces noise between transmissions. 11. What measures faint signal ability? Sensitivity. Lower microvolts better. 12. What rejects adjacent channels? Selectivity. Narrow bandpass. 13. What type of filter is precise? Crystal. High Q for sharp cutoff. 14. What is low SWR? Good antenna match. Minimizes reflected power. 15. What bounces HF waves? Ionosphere. Enables long-distance skip. Section 6. Antennas, power sources, and safety. Last section covers antennas, power, and safe practices. Antennas send or receive waves. Dipole is half-wave wire. Gain in dB shows directionality. Yagi adds elements for beam. Transmission lines like coax carry signal. Impedance 50 ohms common. ERP is transmitter power times antenna gain minus losses. Batteries store chemical energy. Lead acid rechargeable. Capacity in amp hours. Motors convert electricity to motion. Generators opposite. Safety, RF exposure limits. Use dummy loads for tests. Grounding prevents shocks. Fuses protect from overcurrent. Installation, follow codes. Use proper tools. Maintenance, use multimeter, scope for waves. Troubleshoot by halves. Check power first. Radar uses pulses for distance. Antenna rotates. Satellite like GPS gives position. Marine EPIRB for distress. Study these for full understanding. 1. What is a simple antenna? Dipole. Balanced, easy to build. 2. What measures antenna focus? Gain. Concentrates energy. 3. What carries signal to antenna? Transmission line. Matches impedance. 4. What is effective power? ERP. Accounts for gain. 5. What stores energy chemically? Battery. Provides DC power. 6. What is battery size? Amp hours. Capacity over time. 7. What makes motion? Motor. Magnetic fields turn shaft. 8. What limits RF? Exposure guidelines. Prevents heating tissue. 9. What protects circuits? Fuse. Melts on overload. 10. What shows waveforms? Oscilloscope. Visualizes signals. 11. What finds faults? Troubleshooting. Systematic checks. 12. How does radar work? Pulse echoes. Times return for range. 13. What is GPS? Satellite navigation. Triangulates position. 14. What is EPIRB? Emergency beacon. Alerts rescuers. 15. What prevents shocks? Grounding. Safe path for current.